Talking about is the idea of compliance and distensibility, which a lot of people have a hard time understanding how it affects blood pressure and why it's important. And so what we're going to do is we're going to look at a rigid hose, which is something that has very low compliance. And what I'm going to do is I'm going to turn on the water, which you're going to see, and you're going to see that when I turn on the water, that almost immediately the pressure goes up. And so we're really not fighting pressure. Basically what's coming directly out of the hose is going to go directly to the spray. No change in pressure. So I'm turning it on. I'm going to fire, and you can see. Watch that almost immediate as I turned it on, the water is very, very full. Now I'm going to stop this, and I'm still got pressure, but I'm not firing it. What I'm going to do is I'm going to go turn off the faucet. You don't have to film that. So the faucet is now off, so there's no water actively flowing to the hose. And if I do that, you'll see that the pressure will fall almost instantly. So this would be a vessel that was hardened, right, that actually had no distensibility or very little distensibility. Pressure increases very rapidly and pressure falls very rapidly. Now we're going to look at a situation that's a little different. So now what we have is a hose that has some elasticity to it. So you're going to see this hose is actually going to fill up eventually and expand. And what that means is it's resisting filling up because it has some elasticity to it. And that's going to change how the water behaves. And then when I turn the water off, it's going to resist the pressure falling because it's going to snap back as the water pressure goes down. And so you're going to see that's different. This is actually something that has some compliance to it. So I'm going to turn the water on. I'm going to hold the spray on. I'm going to turn the water on. And you're going to see it's going to take longer to build up pressure. It's not going to be immediate. So you're going to see, we'll go out there and see, that over time, you guys can't see this necessarily, but the hose is starting to fill up and it's expanding, and as that happens, the water's going further, right? Because what's happening is some of the initial pressure is being relieved because it's filling up the hose. It's taking up that compliance. And so it takes a while for that pressure to build up in the hose, right? Note this is different than what happened previously. Previously, it just almost automatically went to full pressure. So that's what happens when we fill this vessel. Now I'm going to see what happens. I'm going to again stop this. I'm going to turn off the water. So again, there's no pressure to it. But now we have some pressure stored up in the hose because of that elasticity. And what you're going to see is rather than just falling off dramatically, it's going to slowly die down. Because as the hose collapses, it's putting pressure on the water, maintaining the pressure, and it's going to take quite a while for that water to eventually run out. And so this is the same thing that's happening in your arterial system. You're resisting high pressure buildup, and then you're also resisting pressure falling dramatically because of this compliance.